Okay, let's start our lecture today. And today we have two things. We have first of all what we can say a rule called the Cramer rule, and this is one of the most important rules. And the second thing is how to can find inverse based on cofactors method. Okay, let's start first of all Cramer rule. What is the Cramer rule? If we have A as invertible, so first of all it is invertible. Invertible, that means determinate not equal 0. You know this. And it is n by n matrix, so it's square matrix. And for any B, the unique solution. So here we are talking about just unique solution X. AX equal B given by. So again, here we have A. A must be invertible mat and square matrix, n by n. It's first. And answer will be not one solution, not many solutions or no solutions, should be unique solutions. That means there is or there are no free variables. So how we can find xi, x1, x2, x3? We have something called determinate ai or b over det a. Okay, I will tell you how it here. Let's take this example and I will solve with you. Forget the book now and excuse me, focus with copy here. First of all, just a minute. Let's take this from here. Why? Because I will use exact inside our book. This is the method. Now we have the rule and we have the question. Here we have determinate AI. I is 1, 2, 3, and so on. And we have determinate A. First of all, calculate det A. Because if det A equals 0, no answer. This is trick in exam. Clear? Take care about this trick. Now let's calculate det A. Det A here is delta A or det A. Use what you want to use. Or see my hand, 3 minus 2 minus 5, 4 is equal. 3, 4, it's 15 minus 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 10, so it is 5. Not equal 0, so it is invertible. Clear this? Oh, okay, sorry, 12. Oh, I did mistake. Well, yeah. 12, yeah. It's 10, so it's 2. Where is Hiba? Hiba correct 2 or minus 2? 2. This is I guess 2. Correct? Now, 3, 14, 12, minus with minus, positive with minus, minus, 2 with 5, it's 10. So it is 2. Now, let's calculate another part. Det A I P. I will write det A1. Let me, this is X1. P. What I have to do, I will take those instead of X1. 6, 8 minus 2, 4. 6, 4, 24, minus with positive, 16, it is 40. Now, det A to P, it is 3 minus 5, it changed 2, it's 2 with this, it's 3, 6, 8, 3, 8, 24, positive 30, so it's 54. Correct? Now, last part, x1 is delta A1P over det A. What is it? It is here 40 over 2, it's 20. X2, it is delta A2B over det A. 54 over 2, that's mean 27. That's the answer. How we can check? Take these numbers here. 3 multiply 20 minus 2 multiply 27. It's a check equal 6. You are calculating. It's 60 minus 54. Yes, correct. Any question for this? You repeat. Should I repeat? Okay, I will. Repeat just the green side. Okay, I will. Let's cancel this one. Okay. Muhammad, let's calculate the green one. Now, x1 is delta A1B over det A. This is it is 40 over 2 equal 2. Got it? X2 X2 is det A2B over det A. That means it is 54 over 2. That's 20. Yeah, 20. Clear? Any question more? Yeah, it's 20. 40 over 20 over 2, it's 20. Let's read the question. How we terminate A2? Hiba? Okay, Hiba. See, Hiba, det A2 is 54. Clear? Clear? Det A is 2. 54 over 2 is 27. Clear it? Is it clear, Hiba? Milad. This is okay. This is Cramer. this is Cramer. Cramer said that xi, it's determinate ai b over det I. This is the Cramer rule. This is the Cramer. Cramer said that. This is the Cramer. Is it clear? So in Cramer, you have to calculate det A, det AI, det A1, det A2, det A3, then xi, it is delta AI over det A. x2 det A2 over det A, x3 det A3 over det A. This is the Cramer. Cramer said that. Need more example? Yeah. I will make another example.
مسكت السيارة. بابا مسكت السيارة.
Okay. Delete. Okay, let's go to your book. This is your book. See, this is your book. 27. See, this is A, 3 minus 5 minus 2, 4. B, I took those numbers and I put here for A1. For A2, I took again those and I put here. Then calculate x1, x2. Got it, Hiba? I will write another example about x1, x2, x3. For example, I don't know, I will make a random, I need some question we solved before. So let's write one question. For example, if I have this matrix 2, 3, 1, 1, 2, 0, 1, 4, 2, multiply x1, 2, 3, equal, let's write 2, 1, 1. Okay, this is another example. I will find delta for A. It is 2, 3, 1. 1, 2, 0, 1, 4, 2. Calculate 2, 2, 2. It is 2, 2, 4, 4, 2. It's 8, 3, 0, 1, 4, positive 4, minus 2, 0, minus 3, 1, 6, 12, minus 8. It is 4. Okay, I got it's not equal 0, so it's invertible. With A absolutely. Now let's calculate delta A1 P. It is, see my hand, take this, put here 2. Oh, مع الأسف same. Okay, we'll change the values. Just a minute. 2, 3, 5. Okay, 2, 2, 3, 5. Now we're gonna use 3, 2, 4, 1, 0, 2. Calculate it. Another one. Det A2 P, it is 2. This is the method. This is the method. Who asked me why? This is the method. Now I'm talking about this is C. This is because this is x1, this is x2, this is x3. Now 2, 3, 5. We have 1, 0 to calculate. Equal. Is it clear? Now, last one is this one. I will write here up. Det A3 B it is 211,324, and the last one here it's 235. Calculate. Then you have to find x1. It's delta a1p over delta a equal x2. It is delta a2 b over delta a equal x3. It is delta a3b over delta
أي نسيت مهمل.
Any question for this?
بابا أنا بطل.
Is it clear here, everyone? With me? Who asked Muhammad? Yeah. Should I repeat anything here or is it clear for everyone? Nuruddin, no. Noreen, okay. Hiba, Kareem, Muhammad. Muhammad, it's clear for you? This is Cramer. And this is one of the most important methods. And Cramer rule gives to us exact answer. Exact answer, Muhammad. Give to us exact, and it's easy. And as engineer, this method is, I just 100% you will use this method in your life. So this is one of the most important method in your life. This method, Cramer rule. Okay. Now go another part. Not this one. Is another way.
أي نسيت مهمل.
To find a minus 1. What is this one? Okay. I will write this to you. For inverse matrix, we have usually two methods. First one, it is logarithm. AI gives to us I a minus 1. And I explained this method before. Now we have another one called cofactor method. We studied this before. Now we have this today. What is this method? How we can use this method, how we explain this method. This is our job today, and this is the last topic for this semester. Let's go to your book and talk about classical adjoint or adjoint or cofactor method. See here, we have a minus 1. I will take this to explain you later. here. A minus 1 is 1 over det A, C11, C12, C1n, and this one. Okay, how we can use this method? Okay, I will start with you. First of all, this is called cofactor. The cofactor CGI divided by A, or we can call this one as adjunct or classical adjoint. So this is C11 called cofactor. This is called, all of these called adjoint method or adjunct. So what is C11? How we can calculate C11? Here we are. So we have to calculate C1 and see Algebra. You have something very important. See this. Okay, I will write again, but see the trick. A minus 1, it's 1 over det A. So first thing, calculate det A. If det A not equal 0, it's invertible. If det A equals 0, it is non-invertible. That means no inverse. This is the most important part. Don't start before det A. Calculate det A. First part. Second part. Hujam, we know matrix. Matrix usually is like this. I will write to you. It is C11, C12, C13, C21, C22, C23, C31, C32, C33. Correct? Correct? This is the matrix. Is it clear? Muhammad Hiba. Okay. See here. We can write it's C transpose. C11, C12, C1n. So here we have to make transpose for matrix. This will be like this. C T. Take care, another trick. So this is another trick. So here we have two tricks. First one, calculate determinate and shouldn't be 0. Second one, calculate C1. I explain now C1, 1, 1, 2, blah, blah. And after that, make transpose for this. Okay, now how we calculate C11, C12, C1n? This is the question. But take care, we have two things. First thing is determinate, second thing is transpose. Clear this before going on. Is it clear? Take care for transpose because you will be in the trouble in exam. From now, okay. Now, what's C11? Let's take this example and solve together. Okay, sorry. Okay. Here our question. Return back to the previous week or 2 weeks before, it is C positive. Do you remember this? Did you remember this? Now, C11 for this, it is positive. Now cancel this, minus 1, 1, 4, minus 2. Positive 2, minus 4, it is minus 2. Is it clear? Now, cancel, take this off. See 1 to this. Cancel this, cancel this. It is minus 1, 1, 1, 2, minus 2. 1 minus 2 is minus 2 with equal minus 2 minus 1, I guess. It is minus 3. Now cancel this, C 1, 3. Hujam, how many determinants should we have to calculate here? 9. It's positive for all lines. Cancel this, 1, 1, minus 1, 4. It is 4, positive 1, equal 5. Have we finished? Not yet. We are working. Now another line. C 2, 1. This is the C 2, 1. Cancel this, it's minus. Here 1, 4, 3, minus 2. Minus 2 minus 12 is minus 14. Cancel this, this is minus. So it's C 2, 2, positive 2, 1, 3 minus 2, minus 4, minus 3 is minus 7. Now cancel this, cancel. Hujam, shouldn't we multiply? No, there's no multiply with anything, just this one. C 2, 3. It is negative 2, 1, 1, 4. So it's minus 8 minus 1. It is 9. Now last thing here. C3, 1, it is positive 1 minus 1, 3, 1. It is 1 positive 3 equal 4. If any mistake, excuse me, tell me. We'll check again. Now, but take the method. Cancel this, it's negative C3, 2. It's negative. It's 2, 1, 3, 1. A little bit you need to take care. 2, 1, it is minus 2, minus 3, it is minus 2, it's minus 1, it's 1. C3, 3, it is. Cancel this, cancel this. So it is. It should be minus 7. C3, which one? I will check. If any mistake, excuse me, correct to me. Thank you for any helping. Yeah, which one? For C3, 2, 3, 2, 3. Yeah, sure. We have a mistake here. 8 minus 7, it is 7 minus 7, yes. Minus 7. Here is correct now? No, okay. Thank you so much. Now, 2, 1, it's positive here. Don't forget the sign. 1 minus 1. So it is 2 minus 2 minus 1. It is minus 3. Clear?
Yes.
Now, take these values. Let's check our book. I don't know if it's clear or not. Let's check our book if same or not. Here, our book. Minus 3 minus. It's 1. It is 4. Yes, correct. Minus 7 minus 7 minus 7. Yes. 14. Correct. It's 5. 3 minus 2. Correct. Now, what we have to do? Where is determinate? Det. This is the most mistake. Why? Because we calculated all of these before calculating this. If this 0, all of this are nothing. Got where is the problem?
Wala ba to?
Now it's 3 by 3, a little bit easy, but if you have 4 by 4, 5 by 5, so for 2 by 2, 3 by 3, okay. But see, we waste many times, and after that, maybe there is no inverter. Our matrix is non-invertible. So before starting, before calculating cofactors, C11, this is called cofactor, C11, C3, take care about determinate. Okay, now what is det? In our book, they calculate to us, I guess, determinate was here 14. 14. Det A is 14, calculate. Now it's 1 over 14. After that, how can I write those? See, it's minus 2, then 3, then 5, then 14 minus 7, minus 7, 4, 1, minus 3. It is CT. So first of all, calculate det must be not 0. After that, if no 0, calculate cofactors. But when we studied inverse matrix, for example, and terminate based on our normal method, for example, we said 2 multiply. Here there's no 2 multiply. Here we don't talk about determinate. Here we are talking about A minus. So see, the result here is matrix, not determinate. Same method we used before for determinate, if you remember, to find determinate. We said this is the main method. At that time, result was number. Here, result is a matrix. Take care what we are talking about. In 2 lectures before, we talked about A as a determinate. So result should be number. Here we are talking about inverse, so result should be matrix. We have something same, but here, as you see, we don't have multiply. And here you have to calculate all C's. C11, C1. So how many, for example, 3 by 3, so you have 9. No, we finished. That is finished. This is, yeah. I know that change. Okay, but just a minute. We didn't finish. No, finished. Yeah. After that, we write as a transpose CT. After you have 1 over 14. Cut. You can enter this to everyone, or you can keep outside. Up to you. Is it clear, Noreen? So don't be confused about 2 methods. In 2 methods, we used cofactors. But first method, we find the row or column that has many zeros to find determinate. Here we are talking about A minus 1 inverse. So here too, you must find all C's. You have to find, for example, if I have 4 by 4, so you have to calculate 16. Oh, big number. Yes, big number. And here, see, it's 2 by 2. So I convert from 3 by 3 to be 2 by 2. So it's easy. But if you have 4 by 4, you have to decrease to be 3 by 3. 3 by 3 for each matrix, we need minimum 2 minutes. And you have to calculate 16. So for that reason, minimum for that question, you need 40 minutes. 30 to 40 minutes if you have 4 by 4. And imagine after you calculating C1, C2, C3, C1, and after that determinant is 0. See the problem where? You spent, or you spent, or you are spending now many times to find C1, C1, 2, C1, 3, C1, 4, and so on. And after that determinant is 0. For that, excuse me, in exam, start with determinant. If determinant 0, don't go on. Stop, write no answer. Clear this trick? Don't start to calculate C11, C12, C13 directly. First of all, remember my speech. Remember this carefully. Calculate determinant A before starting. If determinant is 0, say bye-bye, no answer. Should I repeat? Everyone, should I repeat this? Okay. See our book. See, this is our book. In your book also, he did the mistake. He calculated C11, as you see here, then calculated determinant, and this is wrong. First of all, he must calculate determinant for A, then, because here, see, it is 1 det A first. Then adjudicate or adjoint. Or adjoint, that's mean it is CT. Transpose of cofactor matrix. Again, don't forget this is matrix, but based on determinant. You can stay this outside or enter inside. Any question for this?
No.
Okay, what else? This is the last topic for this year, finish. After that, this is cancelled. This is the last topic. So today we studied 2 things, Cramer rule and how we can find inverse based on adjoint method, cofactor method, adjudicate method. All of these are correct. If we go to the end of your chapter and read the questions, for example, make each statement correct. This is important. Try to read this one. So let's check answer. Pisani. And this one. Here. Yeah, exactly. Use the Cramer rules to compute the solution of system in exercise 1, 2, 3, 4, 5, 6. Easy now. Exercise 7 to determine the value of parameter S for each system has a unique solution. Also, this is important. I need value of S. Unique solution, that means there is one answer. Also, this is important. Try to solve by your hand. Compute the adjudicate of the given matrix. He didn't answer me. He didn't ask me find inverse. First of calculate adjudicate, then use theorem to give the inverse. So first what to calculate adjudicate, that means CT in or C transpose, then find inverse. 17, 18, and after that is cancelled. We didn't need one. That's last question for you in this semester is question number 15, 16. After that, all these questions are cancelled. Here and okay, any question?